In general, series are not so nice looking. They tend to be complicated things, and so we have nice rules for how to simplify series a little bit. If you have a sequence, two sequences, Bn, that are convergent, then I automatically know that several other sequences are also convergent. Then so is C times A sub n, where I multiply all the numbers in my series by a constant. I can add the terms in the two series together. And I can also subtract. All three of these new sequences are convergent as well. And you can also simplify them in the following way. So if I have C times A sub n, you can pull out the constant, just like you do on limits. And if I have a sum or a difference, so let me just write it in one statement, an plus or minus bn, you can split it up into each sequence and then add them, the sequence A sub n plus or minus the sequence, the series B sub n. So again, these rules kind of help you when you have complicated looking series. So let's see an example where we have something complicated and try to make it look a little bit nicer. So find the sum of the series n equals 1 to infinity 3 over n plus 1 plus 1 over 2 to the n. So let's start by looking at the end piece here, the 1 over 2 to the n. Let's focus on that series, 1 over 2 to the n. This kind of looks like a geometric series, right? Except my power is not quite correct. It should be n minus 1. So you can rewrite this as 1 over 2 times 1 over 2 to the n minus 1. And then this becomes 1/2 1 over 2 n minus 1. We see now that it's a geometric series. What's my r? 1/2. So does the series converge or diverge?
It converges.
So this just tells me that it converges. The condition is that the absolute value of r needs to be less than 1. Okay, and then remember how we find our sum here? I need to use my formula, a over 1 minus r. So what's a gonna be? 1/2. 1/2 over 1 minus r, which was also 1/2. 1/2 over 1/2 is 1. Okay. So then we know that the end piece, if I look at that as just a series, it converges. So now we need to go back and look at the first piece. So let's look at, without the coefficient of 3 there. So if I look at the series 1 over n plus 1, we actually saw that earlier in an example. Look back, did it converge or diverge? It was the one we used partial fractions on.
Converge.
We saw last time that it, or in the previous example, converges and we found the sum to be 1. So now that I know each piece of these series converges, I can now split up this sum and I can pull out the constant 3. So the series I was given in the problem, I now know it's equal to 3 times the sum from n equals 1 to infinity, 1 over n plus 1, plus the sum 1 over 2 to the n, and I've calculated the sum for both of these to be 1, so this is 3 times 1 plus 1, or 4, and that's the sum of this series. Okay, but we had to know each individual piece converged first in order for me to pull out that constant and break up the addition, okay? Any questions for me on that? Okay, so I picked out 2 problems. Maybe we'll have time to do both of them. It relates to what we've talked about today. So, does the series ln of n squared plus 1 over 2n squared plus 1 converge or diverge? The series is very complicated, right? The formula, it's ln of n squared plus 1 over 2n squared plus 1. And truthfully, we're moving in a direction where I'm going to give you a series, and all it's going to say is, does this converge or diverge? It's kind of like with integrals. You had to figure out which method to use. We're going to learn a bunch of tests, and you're going to have to figure out which test to use. So a lot of times, if I have no idea, it doesn't look familiar to me, I know this isn't geometric, I automatically start with the divergence test. Okay? So let's take the limit n squared plus 1 over 2n squared plus 1. And what are you going to get for that limit? Take a minute. ln of 1/2, right? You push ln as a continuous function. You push the limit inside. And I get ln of 1/2. Is that 0? No, that's not 0. ln of 1 is 0. ln of 1/2 is not. So it diverges by the divergence test. Okay? Oh, diverges by the divergence test. Okay? So all of that stuff where we were taking, and I won't do the other example, all of this stuff that we were doing when we were taking limits of sequences, it's now popping up again. So you're going to have to do some of the same stuff that we did back in that section.